So, hello everyone. Hello, welcome to this webinar that we are hosting for Land. Um, it's a real honor for me to be here today with you and to host this webinar. First of all, I would really like to thank the team because when I first started thinking about putting together a series of webinar, I didn't have any idea about how much time and effort it would take. So we have really great team, and so first of all, a big thank to the team. Now, for me, this is a very special occasion to greet you all. I'm seeing here many familiar names that are joining the meeting. It is a real pleasure. I couldn't visit you in the last few months as I used to do. So trust me, I will be coming over as soon as this situation will be over. So this gathering for me today has an even more special, let's say, flavor. So welcome to all my customers. I consider you more, let's say, as a family, having worked together with you over the last 10 years at Applanix. And a very warm welcome also to the new people that I'm seeing here today. I hope this is going to be the beginning of a new adventure together. So, just to begin, just a few points before starting. So this webinar will be recorded and it will be emailed to everyone in the next few days. So at the end of the presentation, there will be a Q&A session. You can post your questions during the presentation in the question box that you can find on the right of your screens. Anna Jervis, who's the product manager for Land, will be joining us in the Q&A session. So this is going to be really a good chance for you to get in touch with her and to ask your questions. Should we not arrive in time to answer all the questions, don't worry. We will be coming back to you in the next few days. Finally, this is the first episode of a series of webinar, and there will be more to come in the near future. So for the people who don't know me yet, I'll be hosting the presentation this afternoon. My name is Federica Zampa. I'm the Business Development Manager for the Applanix products for Europe and Russia. So as I just mentioned, this webinar is the first episode of a series of webinars that are really intended to guide you through the Applanix world, the products that we produce, and to help you understand in the way we can help you and let's say all the customers in their applications and in let's say in having them successful for any need of positioning equipment and to learn even let's say tips and tricks on how to improve the way they perform the surveys, how to improve productivity, how to improve the accuracy in their, let's say, in their workflow. So this is the webinar of today is going to be an introduction on our world, and we will see together a number of use cases, case studies, and let's say the products that we produce. So I would like to start today's presentation asking you a question. So it's 3 o'clock, so it's time for 3 o'clock, obviously in Europe, time for a coffee and for thinking about this, let's say this question. So how did GNSS change our lives? So let's just stop a second and think how our life was, let's say 20 years ago. So technology developments go so fast and we are really so immersed into our daily routine, our daily life, things that we need to do, that sometimes we tend to forget the way we were used to do things just the day earlier. So every time there is an improvement in our life, we tend really to, let's say, to forget all the troubles and the efforts of the past. So I really like, let's say, this picture because this picture is really representative of a situation where I found myself many, many times in the past. And I think that really happened also to all the people that are maybe on their 30-ish onwards. So just being in the middle of nowhere, getting lost, and trying to understand on a map where we are and how to reach the final destination. How many times really that did it happen? So I love to think that in the past we were really pioneers, let's say explorers. So when we were leaving for a trip, there was so much uncertainty. So we knew at what time we were leaving, but we didn't have any ideas at what time we would have reached, let's say, the final destination. Um, this has, let's say, really changed in the, let's say, with the GNSS that completely, let's say, revolutionized the way we behave. So in the old days, we had to consult maps. And if we wanted to find a service, we had either to, let's say, to look for information on the yellow pages or to let's say, to do the most dangerous thing that you can do in your life. So just go to the place and then ask to the local. So stop a stranger and ask him information. So, excuse me, where can I find this and that? And that was dangerous because either the person didn't know, I mean, how to help you, or the person gave you wrong directions, or even worse, the person gave you directions, but the person next to you in the car, maybe your husband or your, let's say, friends, they got a different understanding from yours. And so then you were, let's say, arguing about which direction to take. So this has been, I think, an experience that everyone had. And nowadays, this has just changed. So, thanks to the GNSS, our social behavior has completely been revolutionized. Today, we even use GNSS for a 10-minute trip when we leave our home and we need to reach our, let's say, the office, just to know the very exact minute we will be reaching the place. So let's say, generally speaking, GNSS is brought a lot of information, awareness. It really is an instrument that can allow you to predict, right? So, I mean, we sit down in the car, GNSS tells us how the situation is, let's say, all over the place, and we can really choose the route to follow. So, generally speaking, if we want to recap in some words what GNSS brought, we could say that it brought freedom, it brought flexibility, guidance, let's say a lot of simplifications, and I would say a very important word, safety. The concept of safety is very important if we want to think about GNSS into the business life, because we have seen so far how the GNSS impacted our private lives, right? But how did GNSS impact the business, the way we conduct business? So let's think about flight navigation. So air flight navigation. So in the old days, pilots, they were finding orientation just in their position, looking at the skies. So looking at the sky, looking at the stars. So they were performing what is called celestial navigation. They were using the bubble sextant, which is an instrument that it's still, let's say, in use today. But yeah, it was really, it was, there was uncertainty. So the pilots were really pioneers. Nowadays, GNSS brought a complete revolution into the aviation industry, bringing a different level of safety in the sky, allowing the to track in real time all the position of all the aircraft. Tracking airplanes has even become a sport nowadays, thanks to the GNSS. How did GNSS change the land environment, so the land applications? So let's go from the sky to the land. Let's think about infrastructure management. How did we perform surveys in the old days? So in the old days, surveyors used to perform measurements from some known points, using, let's say, traversing from these known points or using solar and lunar observations. Surveys were done with theodolites, and every time they were, let's say, punctual measures. So every survey was just was giving you one single point. So nowadays, mobile mapping has completely revolutionized and, let's say, disrupted the way infrastructures are measured. Mobile mapping, with mobile mapping, you can inspect in a very, let's say, in a very short time, a huge number of infrastructures. So you can collect a huge number of points, and you can think of, let's say, tunnels, roads, bridges. You can do so many scans in just, let's say, with so, let's say, little effort, that the way to survey these, let's say, object has completely changed. Now, we can see, let's say, these concepts, let's summarize in this slide. So this slide represents the result of a job that has been performed some years ago. So the customer, he was the Italian Highway National Traffic Board, and they wanted to perform the exact same job, which was extracting the edges of a stretch of a highway, like 18 kilometers, with two different methodologies. So using the traditional topography and using mobile mapping system. And the reason was because the mobile mapping was such a new instrument and technology that they wanted to understand the differences. So I'm not going to get into, let's say, the technical details today. We could, I gave a presentation, let's say, 10 years ago about this, but we can talk about that, let's say, in a separate time. I can just tell you that from a technical perspective, in some points there was let's say, a difference of up to 30 centimeters, and that was not, let's say, due to the accuracy of the instrument, but it was due to the methodologies, that the methodology that, let's say, lies behind the two different collection methods. From the process side, if we look at the table, the results are really stunning. So we are talking with traditional topography about 760 man-hours versus 60 man-hours with the mobile mapping system. And if we check at the numbers of points, we talk about 6,000 points with traditional topography versus like 3 billion points with mobile mapping system. So now, if you just multiply the man-hours by the cost of, let's say, a man-hour, you really understand that there is a huge difference in, let's say, in the economic terms, but also in, let's say, in the technical results. Because with, let's say, with traditional topography, you perform a job and you get the points only for that specific application and that specific job. While with mobile mapping, you get a universe of points that you can access also at a later time to get, let's say, many more informations out of it. So back to the GNSS. The first GNSS satellite has been launched in the sky up in 1960. This is a nice picture. I mean, the first satellite, it looks like really a vintage thing, and it was launched from the US Army under the DARPA program. So please remember this name, because we will be talking about DARPA also in one of the following slides. Nowadays, we have about 2,600 satellites that are up in the sky and that are helping us every day in tracking our position. So I've spoken so far about how wonderful is GNSS, how amazing is the technology, and how it changed our social behavior. But what happens when there is no GNSS, or when the GNSS signal is not available, or, let's say, disturbed? So everyone has the experience of driving in the car, and then you get in a tunnel or under a parking lot, and suddenly you see your car like navigating onto a lake, or, let's say, somewhere else. So what do we do when there is no GNSS? And here it is exactly where Applanix is coming to help. So Applanix mission is to produce systems for giving you the highest and most reliable accuracy in, let's say, in the world, in any application, in any navigation conditions, so with and without GNSS, in any environment, so whether it is land, air, or let's see, for any moving vehicle. So even if you're navigating with, let's say, a car, a bicycle, let's say a boat, an aircraft, we will be always providing, let's say, the vehicle with the highest accuracy in positioning and orientation available on the market. So let's see the company profile. We are based in Toronto, so the headquarters are in Canada, and we have offices spread all over the world. We work with a high number of reseller and partners, and the reason is because we want really to reach directly every customer on the planet. And we have a high number of customers. I have just inserted here a number of, let's say, representative names for the three divisions that we have, which are land, airborne, and marine. So our head office is again is in Canada, but we do have local offices in every region. With the local offices, we do customer support. Our customer support is very well renowned from our customers because we really want to assist our customers in every single step of their experience with our products. So our commitment is really to follow everyone in every single way, in every single moment, and to assist you at best, because your success is really our success. We've been acquired by Trimble back in 2003. Just a few words on Trimble. So Trimble is a Sunnyvale, California-based company. They are working in several different markets. So you can see here in agriculture, building, construction, geospatial, transportation. There are more than 8,000 employees that are working at Trimble, and offices are, let's say, across all the countries. Trimble also develops and does hardware development for GNSS-based systems like receiver, scanners, lasers, etc. The acquisition by Trimble has been really a win-win situation because we, as Applanix, we got access to all their GNSS, let's say, development, and at the same time, so they got access to the most accurate technology to be integrated into their geospatial products. So the history of Applanix is really a history of invention and innovation and pioneers. I really like this slide because it recaps in a nutshell all the milestones of the company. So Applanix has been founded in the early 90s from as a spin-off of Honeywell, the ATC division, so the division for technology. It's really a story of pioneers. So the people that founded the company, they had a great experience into GNSS inertial for military applications, and they foresaw the need of something similar to be launched into the commercial space. So they decided to found the company. And in 1994, the very first positioning system for land and for marine had been launched. This really changed completely the shape of, let's say, and the type of the way the surveys were performed. Because, I mean, from that time on, a new system for having a precise position, even with no GNSS, was available. In 2005, we participated to the DARPA challenge. So I mentioned about DARPA also earlier. DARPA was a program put together from the Pentagon for developing autonomous vehicles, but we are talking about 2005, which is 16 years ago. So nowadays everyone is, let's say, talking about autonomy, autonomous vehicles development with all the difficulties of the case. We worked together with Carnegie Mellon and Stanford back 16 years ago to develop the very first autonomous vehicles ever. And the vehicles that we, let's say, help in developing, they got the first and second place at the DARPA Urban Challenge. So that was a great, let's say, experience. And we embedded all the experience that we did in that specific project into our products. So this is the way that Applanix works. We continuously do research, and we continuously develop our products in order to allow our customers to have always the latest technological developments. In 2009, we launched the OEM version of our products, and that was because our customers, some of our customers, larger customers, they needed some flexibility of integration. So they wanted really to, let's say, to integrate and embed their into their products, into their solution, our systems, and that's the reason why we launched the OEM products. In 2018, we got to 10,000 units shipped, which was really an achievement because we are talking about a niche market. So in a niche market like ours, that was a great success. And then we got to this year, so 2021, we have just celebrated the 30th anniversary of Applanix. We had the luck to hear the stories of the founders, and I mean, it was really it's a story of success, but also of hard times, because when you're, let's say, a pioneer, you had really to face also some, let's say, challenges. Now, I've told you that we produce systems that help you get in the highest accuracy even when there is no GNSS. But how do we do that? So we do that with the integration of two completely different technologies, GNSS, and we have spoken so far about, let's say, the technical details, and also inertial. So the inertial technology tells you all the details of your and information of the motion of your vehicle. So you basically know how fast you're going, you have all the information on the motion, but with inertial only, you don't know your absolute position in the world. So by integrating GNSS together with inertial, you get to know always in a very accurate way the position on your vehicle, whatever the environment is. With this type of solution, we serve a number of markets. So the most, let's say, common market for GNSS inertial, or let's say the most renowned, is the terrestrial, the mobile mapping. But as you can see here, there is a high number of other applications. We work in rail, we work in pavement management, we provide solutions and help our clients for fleet management, vehicle automation, and many other, let's say, many other verticals like that I'm not mentioning here today, forest applications or ports and harbors. But today I would like to focus and give you some examples on how we helped our customers being successful in applications in the markets that you can see here. So how do we serve those markets? So which, let's say, which products? All the products that we developed are for land are recapped here. So I would like to let you know or that we develop both the hardware solution, the integration, and also the software for our products. And this is really a game changer in comparison with other companies, because this is a complete solution that works together. So the accuracy you can get out of a system that it's developed from a company that develops only the hardware, for instance, and then integrates a third-party post-processing software is not the same, because let's say our solution has been, let's say, developed on purpose. It's really tight. On the top, you can see the hardware. So we have the POS LV, which is the main system that we will use for our products. There is the PCS, which is the central processing unit that gets all the information from the other sensors, which are the inertial measurement unit here on the right, the GNSS antennas, and the odometer. On the right, there is the OEM version of our products, which is the AP board. So this is the part regarding the hardware. On the software side, we have Postback MMS, which is the post-processing software. So the software that helps you to post-processing your trajectory in order to get the maximum out of it. We have a Smart-Based Cloud, which is the software for processing the data on the cloud. And we have the great news for land, which is LiDAR QC, that is the software that allows you to bore sight and calibrate your LiDAR and the POS LV in just about 10 minutes. So this is the great news of, let's say, of this year. We will be dedicating separate webinar for everything that you see here. So we will be having a webinar on LiDAR QC, on Postback and MMS, one on the products, but we will be talking more about that, let's say, in the next few slides. So let's have a look now at the case studies. We have solutions for each type of application, and I would like to start today with some case studies on the rail. So the reason why I want to start with rail is because this has been really an emerging market, a fastly growing market over the last, I would say, 4 or 5 years. And there is a number of different applications under the rail umbrella. Typically, I always identify 3 main vertical markets. The first one, which is also, I would say, the most traditional one that we are seeing now today, is the tracking geometry. So we started in the railway industry experience back in the late 90s with our cooperation with Placer. So for all the companies that are listening here today and they're working on the rail industry, you will most probably know about Placer. We work with them to develop together the POS TG, which is a solution that enables to scan the rail lines in a very quick with the tracks in a very fast and accurate way in order to detect faults like cracks or defects or places where you need some intervention. This is a typical example of the way that Applanix works, that we work. We are really always let's say consultant. We want to share our know-how in order to help you to develop your own solutions. We are really here to improve your solutions, to help you and to share our knowledge with you. So for the people who are let's say who work with me, you really know that first of all I always like to sit down and to discuss and to see all the technical details and help you at best with, let's say, all the technical details. Now, back on the track geometry, we're working with a number of customers. I mean, here there are just some names of, let's say, of my, let's say, my dear customers that I work with. It is very, very important when you develop a system like this to have a very reliable unit, because there is no room for error. So there is only one chance to go and scan the line, because obviously you cannot, let's say, interrupt the service, disrupt the service of the people that are let's say, traveling on the rail network. So when you go and scan with your system, you really need to be effective, fast, and accurate and reliable. The second application that I would like to present you today is corridor mapping, regarding rail corridor mapping. So the challenge, here is the challenge regarding BNSF. BNSF is a company that manages one of the highest, let's say, network of freight road in the US. They manage more than 50,000 kilometers, and they need really to check every, let's say, in a very, with accuracy and a very fast way, the condition of the track. So they need to be sure about map vegetation growth, tunnel conditions, clearances, etc. So again, they need to inspect the line in a, let's let's say, in a very fast way and without disrupting the service. So in this case, they integrated our POS LV, so the positioning system, with lidars, with two rotating lidars integrated on the rail car, and the result is the point one, an example, the point cloud that you can see here. And then they have some specific tools to extract also the fixed assets and to check, let's say, the quality and the position and the map vegetation. The third application regarding rail, so I call it ATS, but it would be, let's say correctly, ATS, APS, or anyways ERTMS, so fleet management. So with the increased traffic all over the rail network, and generally speaking, the increased congestion of the transportation, it is really vital to track the position of every moving asset on the rail, and to check, let's say, their position, their orientation, and also, let's say, the compliances with, let's say, the laws of the network, in order to, let's say, prevent accident. Because if there is something that is not going correctly, if the train is not where it should be, if the train is faster than it should go, there are some automatical, let's say, automatism that can, let's say, intervene on the network in order to prevent the accidents. So we could help our customers here, thanks to really to the flexibility of our product portfolio. Because if you think, let's say, about the applications that we have seen so far, so basically, if we think about, let's say, scan track, let's say, the track geometry, in that case, you will need a very high accuracy, because the, let's say, the intervention is, let's say, local. So you will need something that is really up to a centimeter accuracy. While here, when we talk about, let's say, general position of fleet management, you will need a system that it's more, let's say, is less precise, and we can serve all this market really thanks to the flexibility of all our solutions. This is another, let's say, typical application is localization in real time, so of fleet. So we can talk about localization of any type of fleet. So it can be taxi, it can be rail cars, it can be trams. In this case, the customer needed to have all the information in real time on of the trams of the cities in very, let's say, trafficated city center, because they needed to know and to prevent possible accidents. So knowing the speed of a tram, knowing its position and its orientation, it could prevent the, let's say, possible accidents over the network. As you may understand, the situation was quite complicated, because we're talking about city centers, and typically in city centers you have a lot of, let's say, of multipath. But that was also a very, let's say, very interesting project, and it worked out. Everything worked well. Now, let's get to mobile mapping. So mobile mapping, I'm not going to spend too many words here regarding what mobile mapping is, because I mean, it has become more and more, let's say, known, and let's say a kind of now a traditional technology. We will just go through some case studies. So you can see here in the picture, a picture which is quite dated. It goes back to 2007. This has been one of the first systems for developed on purpose for scanning, let's say, for mobile mapping and scanning roads. It integrated the POS LV with two laser 360-degree lasers, and with this type of system, a system like this, you can really get multiple types of, let's say, job performed. So we can see now, for instance, some applications. So this is a scan of a city, of a city. So you can do, as you can see, the point cloud is very dense, and so you can extract a number of informations out of it. In this case, the customer was interested to to build the 3D plan of the roads in order to do future intervention, and this is a typical, let's say, result that you can extract from the point cloud. Another application, in this case, the customer was a customer from the UK, so they needed to get the information related to all the buildings in a certain area of a city, because that area was subject to flooding. So with the information that you can get out of a point cloud, let's say with the elevation information, that could basically simulate which areas could, let's say, go under the water before, and let's say intervene locally with some prevention, and also have all the information of the architecture of the buildings for future reference. Another typical application, and they're talking more and more about this lately, due to also the what happened, let's say last year with a large bridge here in Italy, is the scanning of all the bridges, the overpasses, the infrastructures. Again, mapping also uh, for future reference. Now, this is, let's say, yeah, this is a typical result that you can get, let's say, a modeling of the bridge, and then you can, let's say, like stitch all the images or cameras on it in order to see also, let's say, the conditions, for instance, of the concrete. Now, I would like to take your attention 1 second here on this slide. So why is it important to have a very accurate system for for positioning? So when you do a survey, typically what you do is you drive one lane, and then let's say you go on, let's say there is a roundabout, you go do the roundabout and you come back, let's say, the other way. So what happens if you have a system that is not that accurate is that if there is any object in the middle, let's say between the two lanes, what is happening when you process the point cloud is you will see a duplication of the object. So typically, if you see here this pole, you will see a duplication of the object, and you don't really want to have that, because post-processing, when you have a point cloud and you have duplication of objects, they are not, let's say, overlapping, because the accuracy of positioning was different when you were driving one way and you were driving the other. Well, I mean, that is really an issue, because you will need to correct the point cloud, and that is one of the most, let's say, time consuming and difficult things that can happen when you are working with those data. Now let's go to the another typical application, which is the third, let's say the third and last, I would say, application we will see today, which is pavement management. So pavement management. So maybe not all of you know that when you, let's say, drive in a highway, you basically pay a ticket, and part of the fee of the ticket is, let's say, due to the condition of the asphalt. So the best the condition of the asphalt, the more you pay on your ticket. So you can understand that there is a, let's say, a world really behind pavement management. Obviously, the most important concept in pavement management is safety, in order to also, let's say, you need really to do the survey in order to plan all the maintenance intervention. Now, there is typically when you do pavement management and pavement survey, you integrate a positioning system like the POS LV together with a LiDAR, a specific, let's say, LiDAR, and the result of the survey is what you can see here, let's say, in the picture. Again, I mean, there is a number of, let's say, of items that you want to scan when you do pavement survey. So you want to detect, let's say, cracks, potholes, items like IRI, let's say, raveling, roughness, etc. But I'll give you an example of why it is important to have an accurate positioning system. If you have to scan the pavement of a highway, okay, the highway or a motorway, typically these, let's say, roads will have 2, 3, up to 4 lanes. So the way you scan, let's say, is lane by lane, because let's say, the system can scan up to, let's say, the size more or less of a lane. So the way we do the survey is, let's say, you drive a lane, then you go all the way back, you scan the other lane, and you go the way back, and so on and so forth. When you go back and you process your data, you really want to have, let's say, the lane matching, right? Because otherwise you will have, let's say, a crack, for instance, that starts in one lane, and then it will not, let's say, match and add up on the, let's say, on the next, on the, let's say, on the adjacent lane. So that is the reason why it is important to have a very accurate georeferencing of your data. The same concept of pavement management applies to when we talk about infrastructure. So typically, when we talk about infrastructure, we have we scan, for instance, in an airport, the runway, the building, and also the inside of the building. So there are several applications again for the POS LV. The challenge in an airport is obviously to detect the condition of the runway. So the constraints are that you need to scan and to have always under control the condition of the runway, because it is subject to continuous stress due to the continuous landing and taking off. You need to do it fast because there is no time. You cannot, let's say, close, let's say, an airport. You cannot disrupt the service. And so typically they do this integrating the POS LV with a LiDAR solution, again, to detect the accuracy, the condition of the runway. This is a typical, let's say, an example. Here we help the airport in Bologna to do a survey of the condition of their pavement. This has been done by Siteco back last year, a couple of years ago. But anyways, you can see here the job was performed overnight, and they got the information of the areas needed intervention in a very straightforward way. So which ones are our products? We can recap it here. So the POS LV for the hardware, OEM version, and then POSPAC MMS, which is the post-processing software. Here, there are our products in a nutshell. So on the right, you can see the typical integration, and the typical systems. So the systems are all integrated with the same architecture. They're all export free, so no problem about exportability. And the only thing that changes among the different systems is the inertial measurement unit. So typically, the inertial measurement unit is really it is the core of the system. And according to the type of application and the job that you need to perform, you will be choosing one system or, let's say, another. On the left, there are two systems that are, let's say, different. As you can see, they are much more, let's say, they're smaller, they're more portable, lighter, more, let's say, more flexible. And we introduced them in order to be able to serve markets like the fleet management, or markets where, let's say, different technical need was, let's say, was required. We also have all the OEM version of our products. We will be talking more about our, let's say, product portfolio in the next webinar. So this is just an overview of the way we serve the market. POSPAC MMS is really a great software. It has many different features. It is at its eighth development. So I mean, we've been working on it for basically all, let's say, the Applanix history, and we will be doing a deep dive into the software again in another webinar. Then the big news that I mentioned, this is going to be analyzed separately at a later stage, in another, let's say, chapter for our episode. It's LiDAR QC. So LiDAR QC was a tool that we developed for airborne and that we launched just this year for land. I will only tell you that with LiDAR QC now you can boresight the POS LV with your LiDAR in about, let's say, just 10 minutes, which is really a game changer, because I mean, that allows you to do something that takes hours or anyways days in just with basically no efforts. So we got to our conclusions. The only thing I would like to add here is that, let's say, we are really here to help you, to be a resource for you, to help you being successful, and to be your consultant. So we really sit down with our customer, we help you, we share all the know-how that we have put together over the last 30 years with you. So what's coming next? So the next episodes will be an overview of our product portfolio, a deep dive into POSPAC MMS, a deep dive into LiDAR QC, so how our boresighting tool works, and a chapter on how to improve the accuracy of your trajectory with PFix. So I'd like to welcome now here, there is with us, as I said, our land product manager, which is Anna Jarvis. So welcome, Anna.
Oopsies. There we
Anna, are you
go.
here? Yeah.
Yeah. Sorry about that. Had the camera off. Hi, everybody. Yeah, great to be here. It was a excellent discussion there, Frederica.
So thank you, Anna, for joining. So Anna will be answering today our all the questions that we have received will help us. I mean, we have many questions. So let me just start with some questions. Then we will be coming back to you. Let's say in a separate email if we cannot, let's say, answer now. So the first question is, so how do you integrate the POS LV with external sensors?
Yep, sure. So I can take that one. So integration is quite simple and straightforward, both for cameras and scanners. I guess in terms of the cameras, the POS LV can accept an input, for example, the camera mid-exposure pulse, and that will create a event file that basically time tags every photo event that's captured. And then we would use this, I guess, time tagged log to georeference your photos by using the post-process trajectory, which we call the SBET. And then for the scanners, most often scanners require a PPS signal, which the POS LV can be configured to output, and as well as it usually needs a UTC time message, which we can also output either over serial or Ethernet. So yeah, integration is very simple and straightforward. And of course, we have our great support team can help take anybody through any issues they have with that.
Okay, thank you, Anna. So, second question, again for you. So, what makes Applanix products different from competition?
Okay, yeah, another great question. I guess the two things that come to mind would be quality and then, like I mentioned just now, support, so excellent support. In terms of the quality, so as Federica mentioned in our nice chat here today, being part of Trimble, we can leverage our connection with them to always have the latest and greatest advancements in the GNSS technology side of things. And then we work extensively with all of the IMUs, developing new ones, calibrating and fine tuning the ones that we're using to get the best performance out of every IMU we're using, such that if you bought an IMU similar price, let's say off the shelf, you wouldn't be achieving the same performance that we're able to based on all the efforts that we're making in our labs to calibrate and fine tune them in our complete system that we totally control on our side. That's another great question. Thanks. Oh, actually, I also want to mention our support team. I can't say enough about them. They're available globally. We have a large team of experienced delegates, and they're always happy to answer any other questions, help people with any issues along the way. So basically, quality and support would be what come to mind.
Great, thank you, Anna. So, another question here from this is from Alex. So, as far as the LiDAR QC, can you please indicate which LiDAR this solution is compatible with?
Yeah, another great question. So at the moment, it's compatible with the Velodyne PCAP file for the VLP16. We are working on adding other ones, but otherwise it's generic binary format is also accepted. So it's uh, any LiDAR can be compatible with the LiDAR QC. Thanks
Excellent.
for
So,
that
any
question.
LiDAR is compatible. You just need to basically convert it in a standard binary file, right?
Exactly, yep.
Okay, perfect. Um, yeah, so there is a number of questions. Okay, we will get we cannot answer to all of you guys. So we will really get back to you in the next in the next, let's say, near future. So yeah. Okay, so I think yeah, this is basically all for today. Thank you. I would like really to thank you all for your attention today, for, let's say, being here, keeping us, let's say, yeah, questions, keeping us, let's say, company in this afternoon. I hope to see you very soon, let's say, in person and shake hands. And for any inquiries, any doubt, whatever information you will need, you can reach me at the email, and I will be really, really happy to follow up with you. So thanks again for listening today. It has been really a great pleasure. Bye.
Thank you. Bye.
Uh,